Good afternoon, everyone. Welcome to this afternoon's webinar sponsored by Autodesk. I'm Christina Fugis with Mold Making Technology Magazine. Today's topic is validating and optimizing your tool design with Moldflow. Thanks again for taking time to be with us today. This webinar will cover understanding how to validate cycle times, meeting part specifications, and optimizing processes. Our presenter today is Caitlin Shappett. Caitlin graduated from Penn State University with a Bachelor of Science degree in Plastics Engineering Technology. She has been with Autodesk for 2 years and is a technical support specialist, primarily focusing on Autodesk Moldflow. As you listen to the presentation, please feel free to ask questions by typing them in the questions panel on your computer. Caitlin will answer them at the end of the presentation. And as a reminder, this webinar is being recorded, so you'll be able to listen to it later online. And now here's Caitlin.
Thank you. Today I will be presenting on validating and optimizing your tool design. As mentioned, I'm Caitlin Shappett, a part of the Moldflow technical team at Autodesk. Today we will discuss the challenges, design phases, simulation methods, and then have brief discussion at the end around Q&A. There are many challenges you're faced when designing a mold. The continual change to ensure manufacturable parts, the process type, the material, the application in which the final product is used. The list is nearly endless. Many of the challenges come from wanting to make a part quick and innovative. Some of the trends that we see at Moldflow are powder injection molding, the importance of surface quality, overmolding, conformal cooling. The list goes on and on. What we see today will change tomorrow, and the boundaries will continue to be pushed with different technology. Using simulation with that can help optimize and validate these new technologies. Here we have an example of multi-component technologies, new LSR materials that are available, overmolding thermoplastics over thermosets and vice versa, and then thermoplastic composite hybrid overmolding, just to give a few examples. This is a list of the processes and analysis types that we currently offer inside of Moldflow. We are continually improving and enhancing our software to stay in the forefront of the technology that is out there. In the beginning stages of your design and how you want to manufacture it, you have to consider the application and function to determine the best suitable process type. Is it overmolding a plastic component? Is it using Mucell to lightweight? Is it a two-shot sequential overmolding? Understanding your application criteria helps formulate the end design. What is your quality criteria? What is most important to you and your customer? Is the criteria something that can change, or is it set in stone? Using simulation, you can evaluate various inputs to determine what best suits your needs. There will always be variation in a manufacturing plant, whether it's material variation from each lot, machine wear and cloning, mold wear, and so on. How do you overcome that? While not always feasible, having regular maintenance on your molds and melt tests on your materials is one way to help maintain consistency. Before even designing the mold, you've seen, and I've talked about briefly, all of the different considerations that must be made up front. We've gone through those challenges and considerations. Now let's look at the design process. Start optimizing early and often. Here we have some of the concerns during the mold design process. You've got the actual part design phase from concept to material selection. piece part and prototyping, to the actual mold design, in which we need to consider the layout of the parts, the feed system, the cooling channels, quoting of the actual tool, and then we have to also consider process development, how stable our process is, how we can optimize to achieve product specifications, and then maintain achievable cycle times. Or lastly, we can troubleshoot during production when issues arise. Traditionally, it's seen production troubleshooting tends to fall in the red line. You try to fix issues after the fact, while up front, the green line gives a false pretenses of saving money where you're spending more money troubleshooting issues. Again, using Moldflow early and often during initial design, then using Moldflow to optimize has proven to save time and money throughout the process and its entirety. To get started, using Moldflow in the part design phases allows you to trust yet verify the nominal wall thickness, ensure draft is appropriate in the appropriate areas to ensure the part will actually eject, and then verify where undercuts are. In addition to verifying the part is manufacturable, you can also change CAD features and mesh to simulate how flow, amongst other results, are affected. And this can all be done in the initial part design phase. You're able to preview the fill by placing an injection cone on the CAD and verify how materials will fill the part and where weld lines and air traps will occur. You need to ask yourself if the location is acceptable or if the surface is a Class A surface. Are weld lines going to cause aesthetic or structural issues based on the product functionality? Do I need more than one gate to reduce pressure to fill a part? You can run a gating suitability test to verify where to gate the part as well. Then, once happy, run a fill analysis test to find out how confident you are the part will fill, and using the quality prediction to determine the quality of the part and how to make it better. Lastly, when setting up your process window and starting point, there's no need to throw dart at a dartboard, if you will. Using a molding window analysis and Moldflow allows you to quickly, within seconds, determine your process window, and also allows you to compare different process windows for different materials. From part design, let's now talk about the actual mold design phase. Initially, a job may need to be quoted, then the real fun begins. Oftentimes we hear of customers using experience, which is great, but missing the mark a bit, or better yet, was just at a customer not too long ago and mentioned no quoting jobs for various reasons. Using Moldflow, you can predict the time to reach ejection temperature and temperature variation across the part, thus better predict the cycle times. There are many decisions that need to be made and many consequences to the decisions when designing a mold. Understanding different trade-offs for different types of part geometry, material choices, processes, mold design choices, including steel types, textures, and mold finishes. Oftentimes the main function is aesthetics. Sometimes a part functions, but a visual defect creates this perception of a lesser quality part. Thus, each part must be matched to the best process type, mold tooling, and one of the hundreds of thousands of different materials out there. Starting with the runner system, the initial runner layout is a large consideration. need to determine if it's geometrically balanced, if it's rheologically balanced, what the pressure drop is through the runner. It helps answer, Moldflow can help answer, if you have flexibility to change the runner design, can you do that? And then compare one layout versus another layout. And then helps answer, what if my runner isn't balanced? What do my pressures then look like? What do my short shots look like when I run my fill analysis? So using Moldflow, you're able to optimize and validate some of these questions. What kind of gate system should you use? It's a huge subject, but for now I just want to point out the transition and the gate land area. Using simulation to get the ideal gate location and then get an ideal flow rate. Using the flow rate in the cross-section of the area can be used to determine a shear rate. Can that round be elongated to a rectangular cross-section to increase those areas? Again, simulation helps answer and validate some of these questions. Other considerations, depending on your runner system, is if there is going to be jetting on the part, such that it might cause aesthetic problems. And you can see here in this example, forms weld lines and creates blemishes or other internal stresses. Being able to simulate that helps answer those questions as well. Another consideration is if you're going to use a hot runner system. What happens when you do? Are you able to slow down the flow front to avoid hesitation and weld lines? And here we have two examples from Inco and Synventive. Using Moldflow, you can better control the valve gate timings, again, to slow down that flow front and create a more uniform flow front. Again, then you can take it a step further and compare the valve gating with the valves all open versus instantly opening and then a variable opening. This, of course, is dependent on the part functionality and criterias. Of course, we know a part needs to be vented, and without vents in Moldflow, we assume perfect venting. Running a simulation without the venting to determine where air traps are, and then adding a vent to verify those air traps are removed, as well as weld lines. The next consideration is the placement of the cooling and heating channels to ensure uniform heat removal. In this example, we have our cooling channels spaced out around this part and have a localized hotspot. Moving the cooling channels closer to this hotspot and this one down, you're able to see that we can get a more uniform cooling. There are several cooling analyses that can be evaluated in Moldflow: steady state, transient, and multi-cycle transient. Depending on the criteria will likely depend on which cooling analysis you want to run. Do you need the fine detail of startup from production, or will a steady state analysis get the job done? The more detail you're after may increase the analysis time, but imagine being able to predict how hot an insert is at a specific time and how that affects your cycle time. Let's look at an example. We have the original part design on the left with simple circuits and part. On the right, we have an optimized design with baffles and inserts and a more complex cooling system. There is a revised design picture on top, these two, versus the original design on the bottom, you're able to see the part on top has a more uniform temperature across the part versus the large heatsink in the original design. By comparing optimized cooling channels and inserts to simple cooling channels, we're able to see the uniformity that it brings. To take it a step further, you can even get more complex and add conformal cooling in channels in Moldflow to get to those tough to reach places. This too helps ensure faster cooling and therefore faster cycle times. Using our integrated CFD mesher, we simulate the flow coolant through the channels to determine the velocity and where the dead flow is in the channels where we aren't removing heat. Here we'll look at another example. This example shows the part center gated with a nylon material and conformal cooling versus conventional cooling. Broken down, we can see the maximum mold temperature, cycle times, and cycles per hour with conformal versus conventional cooling. The difference is 35 degrees Celsius with a 4-second cycle time savings and 140 shots per hour. That's huge. And then you can compare the differences in deflection. The conformal cooling on top versus the conventional cooling on bottom. You see a 17% increase in deflection with the conventional cooling. So really at the end of the day, it comes down to analyzing throughout the entire design to optimize and validate your tooling. And to take it even a step further, depending on your quality criteria, again, is being able to run a rapid heating cooling analysis, which has helped to improve surface finish. Lastly, we want to be able to consider steel types to determine how steel affects our overall deflection, temperatures, cycle time, and so forth. These videos, the one up top here, you're able to see transient analysis with the temperature of the insert at 2 different points during the cycle, and we're able to overlay that to see how hot it gets throughout the cycle time. The video on the bottom, as it navigates through, we're able to see the hot spots on the part above the transition temperature. This, of course, will help determine, if that part will be able to eject, if the hot spots in those areas are acceptable. But being able to compare those side by side again helps answer the questions of, is this part manufacturable and how much time can I save with my cycle? And then on the right here, we're able to compare different temperatures of P20 and a mold max insert and evaluate the deflection of those. One thing to point out is the vast database that we have inside of Moldflow, which are able to pick different steel types for inserts, mold materials, and so forth, and then the ability to change some of those thermal and mechanical properties. Next, we can talk about optimizing our the process development. In the beginning, if you recall, we discussed a molding window analysis, which helps give you a starting point in your process settings. But from there, what you'll want to even do is optimize it even further to be able to see how different variables affect your overall quality of your part. So to do that, you're able to run a design of experiment inside of Moldflow. This, of course, helps save time and money being able to do it virtually versus at a press and having to, stand at a press all day and measure parts and whatnot. So in conclusion, determining your mold design should be optimized, again, and optimized and validated at all stages of the process in order to best meet your specifications, cycle times, and quality criteria.
All right, thanks, Caitlin. Let's see.
Thank you.
I want to remind everybody that there is time for you to submit your questions. All you need to do is type them into the question pane, and we'll go through them as they come in. But we might as well get started and jump in with some. When adding venting based on an air trap, when run without vents modeled, do all the vent locations need to be added?
Yeah, I mean, so when you are running a venting analysis, or when you're running a perfect scenario, so without vents, again, it helps determine where those air traps are. And then when you run your venting analysis in Moldflow, if you don't already know where those vents should be, you should, put them where you have those air traps are. One thing to note too is the ability to specify the length, width, and thickness of that vent in those areas. The nice thing about Moldflow though is if you wanted to run a single vent in a specific area, run it there and then look at the analysis, and then you can run another venting analysis if you determine that you do need to add more than one vent to a location.
Okay. Before we move on to another question, would you mind, do you have your contact information that you could put up on the screen in case people want to follow up with you later? We could have your, oh, I see it up there. Never mind.
Yeah,
I see your email address up there. If anybody has questions,
if anybody wants to directly email me, that's very okay.
All right. How can I use Moldflow to predict cycle times? Can you get into that a little bit more?
Yeah, so from an upfront, and I think I hit on this a little bit, from an upfront and initial testing, you're able to use a molding window analysis, which gives you fairly accurate starting place. And then once optimizing your process, you can infer, from various temperature results as well as cooling results, where your cycle time should be.
Are there any common misconceptions about Moldflow that you hear when you're out in the field with customers? Things that people don't really understand what the software can do, that comes up repeatedly.
Yeah, common misconceptions. Yeah, certainly there are different misconceptions that come up. We can get into the fine detail, or it can be something as different as our meshing technology. But if there's something a bit more specific, we can touch on that a bit later.
Here's one. Why does Moldflow over-predict clamp tonnage requirements?
I think oftentimes it probably can be boiled down to a couple things. Sometimes I will find that if the orientation isn't set up properly inside of Moldflow, so in the positive Z direction, a clamp tonnage can be off, but also different input settings can also help determine that.
Will Moldflow show uneven fill on a balanced runner and prove the need for adding melt flipper?
Will Moldflow show uneven fill on a balanced runner and prove for adding a the need for adding a melt filter. It'll show pressure differences and shear rate differences depending on how you have your your analysis set up. It certainly can show if you will have very varying fill patterns as well.
Okay. Can you use Moldflow to simulate mold inserts that are different from the tool steel?
Yeah, you certainly can, and it's definitely highly recommended, especially since different mold inserts have different HT values. This obviously will affect the part differently, and yeah, this should definitely be a part of the validating and optimization process.
All right, while we're waiting for a few more, I want to remind everybody there's still time to submit some questions for Caitlin. Just type them into your computer, on your computer screen. When it comes to cooling, does Autodesk offer training on cooling and cooling channel design?
Yeah, we definitely do offer training. In fact, 2 of my colleagues on our adoption team give monthly free webinars, in which the last one they did was on this more advanced topic. So definitely encourage you to check that out. And if you have questions or want the recording, shoot me an email and I can get that over to you.
Have you guys noticed, conformal cooling itself nowadays it's been around forever, but it has this almost like a resurgence because of the whole additive manufacturing, 3D printing way. Have you noticed more and more shops using conformal cooling? Have you noticed this trend, or are people still skeptical? Is the cost prohibitive? Is there a lack of understanding? What's your take on that?
I would say yes to all of that. The conversation definitely is coming up more and more, which is awesome to hear. And then I think there still is a bit of skepticism out there. It's not a cheap thing to do to print conformal channels, but I think more and more companies and people are starting to drink the juice a little bit more, so that's good to hear.
Yeah. Once people start understanding the long-term benefits of getting into that, do you see it coming more? Do you see more mold shops understanding it, or is it trickling down from the OEMs and like the tier suppliers kind of forcing that upon them?
I think it's got a little bit more of a trickle-down effect, and then also I've been seeing it come up quite a bit in resin suppliers that I've been in as well.
Oh, that's interesting. Okay. Okay. Does Moldflow have a part cooling freeze analysis, meaning similar to gate freeze, some areas of the part may freeze too early, preventing packing pressure reaching some areas of the part? So basically, a part freeze analysis based on time.
Right. Great question. Actually, the way you would determine this is by taking your transition temperature and changing the property in Moldflow. So you would take that transition temperature and then input it into your temperature plot property under the single contour result. And I can actually, Christine, if afterwards, if you can send me a list of that question, I can send like a step-by-step, but that's how you would get around that.
Okay, not a problem. Let's see, there's a number of them coming in. Let me see if I can decipher this. The warpage values are 15 to 20% higher than the Moldflow report's dimensions. What would be the reason? And then, are you seeing this, Caitlin? There's additional...
Yeah.
The same person keeps adding to the question?
Yeah, there's a number of different things that it could be attributed to. It's not uncommon to see a difference between Moldflow and reality, but it could be something as simple as your mesh, but it could also be something related to the material file that is being used in the analysis. So if that's a common trend and theme that you are seeing, it's probably advantageous to reach out to, myself, or if you know someone local to the area that can kind of help troubleshoot what's going on as well. But
All right.
oftentimes when you start seeing those differences, it's material related. I found anyways. But and also setting up your simulation to be accurate to what and how you're running at a press.
All right. It looks like we went through the questions. We still have some time if people want to submit more questions, and Caitlin's email address is up on the screen if you want to follow up with her directly. The gentleman that is asking for the part freeze analysis, that will be sent to you. Thank you for putting in your email address. And this is recorded, so if anybody missed anything or wants to share it or listen to it later online, it will be up on the website when this webinar is finished. Caitlin, do you have anything else you want to add or sum up or leave any parting words to the audience?
I just want to thank you all for your time today, and yeah, you have a good weekend.
All right. Thank you so much, Caitlin. And thank you, everyone. Again, this is Christina with Mold Making Technology, and look for the webinar online at moldmakingtechnology.com. Have a great day.